So, what led you to start building Number Zero and IRO itself?
Totally. My co-founder and I met. We were both working in and around the IPFS project, which is the Interplanetary File System, and we decided to start Number Zero really as at a sort of an impasse for the IPFS project, where we realized that what we felt was missing was just like a really great hardcore engineering take on a good peer-to-peer networking library, and that we felt like that would be a sort of step function change if we had that in like a really like Google Chrome grade engineering work. And so that meant like writing in a systems language and really taking things down a couple of layers. And we could only do that because the IPFS project had really illuminated this opportunity in this incredible space for doing reviving a lot of peer-to-peer thinking. And that's sort of what drove us here. And so we started the project right around that. Basically just, hey, let's do the most soup to nuts performance oriented, runs in as many places as possible iteration of a peer-to-peer networking library. And let's try and do that in 2025 or 2023 when we started it, with as many lessons as we've learned from other projects like WebRTC and libp2p as we could.
So, what was the sort of moment where you decided that this layer of the stack was something that was really important to you? Just like sort of digging in a little bit deeper, because like peer-to-peer is pretty, like, I don't want to say it's like niche, because obviously there's a long history of peer-to-peer applications, but like what about this space like really compelled you?
Yeah, I think I think it's completely fine to call it niche, like, because it is. Like, if we just think about the amount of traffic that just flows over HTTP to regular servers, that's the vast majority of the internet, right? And so, like, it's absolutely niche, and it's absolutely this small space. My involvement actually started doing a lot of government data archiving work in 2016, where we started to realize that sort of like took this core thesis that like there are large swaths of the internet that are just gated by DNS, right? Like you can turn off a whole bunch of the internet. And you can turn off a lot of access to the internet just through DNS controls. And this is location-based addressing, or this is just the fact that we all use URLs to describe and reference stuff on the internet. And we started to like problematize that in our heads. It's like, wait a second, why does the internet work that way, right? Like, and could it work better, or at least could we have a viable alternative, right? And I don't think this is necessarily IRO is very much not a project that's aimed at replacing HTTP. This is much more like thinking about a world in which we have more tools in the toolbox to kind of build on and iterate with. And so I think that's really what got me excited. Was this early project. We're doing a lot of archiving work. We're like, wait a second, why does this work this way? Can we come up with a better approach or a viable alternative that would allow us to sort of move data in ways that are a little more friendly to the interest of the users at hand, right? In that use case, we have a whole bunch of users who are just trying to get data sets to do their regular day-to-day work. In this case, it was on climate change analysis, right? Just downloading daily weather, which, like, if you look at NOAA in the US, they produce like on the order of a petabyte of data a week, like just really silly amounts of data. And making sure that you have continued access to that. How does that look? How does that work? How do you manage that infrastructure? And then now we're officially down in the internet tubes trying to figure out how we move bytes around and how people access those bytes. And lo and behold, you're starting to like ask questions that are pretty foundational to the networking stack.
IRO has a pretty unique philosophy when it comes to peer-to-peer compared to other projects. You've said, I think in other posts online, that other systems try to boil the ocean and do a whole lot of things. I was reading an article where you guys talked about libp2p and like it's doing a whole bunch of stuff, and IRO takes a slightly different approach. Can you detail what that approach is to us?
Totally, yeah. I think, and this is not to throw shade, right? Like there's less, and one of the things when we talk about like a modern peer-to-peer library, we've seen this sort of trend over the last 10 years of work in this space, I'd say, where the metaphor I like is like you're trying to build an electric car, right? The whole world runs on gas, and you want to popularize a new way to do the same thing, right? You still want to, like, it's still going to be a car. It's still going to get you from A to B. It's still going to be a thing that connects to other devices and moves bytes around. But you have this like cold start problem of like, to have an electric car, you need an electric charging station, you need a gas station, you need all of this infrastructure that just like doesn't exist. And then you need like plants to figure out how to make that stuff. And you need all the pieces that go into a car that maybe you don't make. And so now you need like an electric car carburetor, which actually you don't. The metaphor breaks down when I start to talk about the internals of a car. But like the point being, you saw this sort of boil the ocean approach for a long time. Hey, we're going to try and do it peer-to-peer. We're going to do the connections, and then we're going to do every piece of the stack between the raw connection all the way up into user space. We're going to tackle problems like authorization. We're going to tackle problems like synchronization. We're going to tackle problems like it just kind of goes on and goes on and goes on. And the joke that emerged internally was, or a slogan, I guess, is like Nginx published by Postgres, right? Like we don't see this in the other space where it's like, you don't expect the Nginx team to ship a database. That would be ridiculous. Like they make reverse proxies, and that's hard enough. And we really, when we try to kind of reinvent the stack, when we try to get people onto a different fuel source, it really invites, it's very tempting to kind of want to do everything, to build the entire car. And we don't need to do that. We don't need to boil the whole ocean. We can just focus IRO specifically on this incredibly low configuration, incredibly reliable piece of technology that just does one thing really well, which is you get a public key and you can dial the device by public key. It now works like an IP address. And that's the way that we think about connections. And that's the thing that IRO provides. Everything else is a layer on top that's open to community to iterate upon. You're able to compose that however you want. We have lots of people who have like sort of, as we've opened up that space, lots of people have come in to fill it in a way that I think has been very fun and exciting to see from our perspective. But that's what we mean by don't boil the ocean. It's just like, take this new approach to building a peer-to-peer project. Can we just really have the one primitive that we felt that we were missing, which was just really, really, really good, really reliable connection? That's the thing that we are shipping and continually trying to improve upon. Everything else is left to the devices of the community.
Okay, so IRO, a project to help facilitate those really, really good peer-to-peer connections. Can you like kind of package up, like give us a sales pitch? What is IRO like from the sort of like full definition, and then like what does the rest of the ecosystem around IRO that you're building kind of look like? We're going to talk more about specific aspects later, but I just like want to give people a good overview of like everything that you're trying to work on here.
Absolutely. We describe IRO as P2P quick. And so if you know what the quick protocol is, that is, it has now been anointed. It's going to be HTTP3. A lot of the internet traffic runs on quick. And that sort of highlights a couple of things about IRO that we really like. It's peer-to-peer. And so it's, fundamentally your technology is going to be connecting devices that couldn't previously connect easily. And it is based on standards wherever possible. And so like we use bog standard stuff wherever we can, referencing IETF specs wherever we can. And so the project itself is really intended to give you at the highest level this really basic abstraction of every device that you want to be dialable gets a public key, and that public key is then discoverable and dialable from any other device in the network. We also lean into quick in one other way, which the quick spec leaves open this thing called the application level layer protocol name, or ALPN. And that's where we do all of our protocol plugging. And protocols are basically like HTTP middleware. You can compose them however you want. You can use them to do different things. And so some examples of that for us are like, we have ones for data transfer. And so just, hey, do I want to take files, which we call blobs, and have that move around in an easy way? Great. Another one is for like broadcasting messages. And so we can build these things called gossip swarms, and we can broadcast messages to all nodes that are in a given topic. And so like you can build publish subscribe patterns based on that, and all kinds of different primitives. And then all the way up into audio and video, and some other experiments that are running, and then integrations with existing stuff. So it's also technically an IRO protocol to take something like auto merge, the project for CRDTs from and switch, and have that run on top of IRO's peer-to-peer networking stack. And that would be the auto merge protocol for IRO. And so that's kind of the way we think about it. And the way the developer experience generally is start a project, create an IRO endpoint, and that's what gives you the node ID, add whatever protocols you want to add. And that's how you compose together the functionality that you would have done in HTTP world to get whatever features you want to put in your app.
So let's dig into some of the like technical details for a little bit. So you sort of mentioned IRO. You're making these like very like high success rate connections between two peers. What happens under the hood to sort of facilitate that? So I saw in the docs there's this like reference to magic sock, and you have like a hole punching approach. So like, what does all this mean, and like how does it all fit together?
Totally. hole punching, just for those who like don't know what that term is the whole problem we have here comes from IPv4, right? The idea that what we have in all of our routers at home is this thing called network address translation, which I won't bore you too much with the details of that, but basically it means that your device sitting at your home behind your home router doesn't have a public facing IP address that's really easy to dial. And so we have to punch a hole through the network's firewall, which sounds bad, but is actually really good when you mean to do it. and that's the way that we can get direct connections on the internet. IRO takes a really specific, very modern approach to how we do this. And it's also pretty pragmatic in the sense that the emphasis here is it should work 100% of the time, even if it's not actually possible for you to hole punch. If you are working in a corporate environment, often that's the easiest place to see where they just won't allow this to happen. And so in those cases, what will happen with IRO is you will still get a connection. You'll just be talking through an encrypted relay. And that encrypted relay will still be using quick connections over the hood. And the relay can't see the conversation that's happening. It can just facilitate it. And so it's no longer direct, but it does work, right? And the really cool thing that's quite magical about this is using a combination of quick and a number of really difficult networking techniques. IRO will just dynamically pick the right and best path through the internet for the connection as it's happening. And so you can imagine these classic things that often will trip up an app today, where you start with an app open on your phone, you start a request, and then you walk out of your house and you leave Wi-Fi range, and now all of a sudden you have to refresh things. IRO does not have that problem. We figure out which packets have not been sent, we back pressure manage those and send it for you. And we will figure out, hey, you have a direct connection. If you flip on your VPN and all of a sudden your IP address moves to a different country, IRO can still manage that and keep those packets flowing through that. And so it's that ability to sort of negotiate changes in network topology as that connection is happening and keep it alive and not lose packets is the real magic. So yes, we're trying to establish direct connection for you, but we're also trying to get you just generally a more robust connection between the two devices. Sometimes that's the server, right? But it's useful in either context.
Yeah, I think a lot of people listening to this will probably have experienced, it's like you're on your home Wi-Fi and you walk out of range and it switches over to cellular network and you lose connectivity, or you can't access something that you're previously accessing, or whatever. It happens all the time. So it's probably a much harder problem than it seems like to solve that.